Before we begin the proceedings, I would like to acknowledge and pay respect to the traditional owners of the land on which we meet, the Cadigal people of the Eora Nation. It's upon their ancestral lands that the University of Sydney is built. As we share our own knowledge, teaching, learning, and research practices within this university, may we also pay respect to the knowledge embedded forever within the Aboriginal custodianship of country. I also want to pay respect to the elders, past and present, and any Aboriginal and Torres Strait Islander people present today. I also want to pay respect and celebrate the indigenous knowledge that Aboriginal people have developed for thousands of years about stars. We came last night from an amazing activity across the country. I was happy to be part of that, but also I am happy to celebrate what we can learn from indigenous people. And today we are going to have a very interesting talk. This is the last talk of our 8 indigenous seminar series, and I am very happy to see how more and more people join us every time that we have this series. This year, we try to focus a little bit on mathematics, physics, and environment. And next year, we will focus more on physics. And I appreciate that our colleagues from physics are here today and colleagues from other departments. Also, I want to acknowledge the support of the DVC Indigenous Services Strategic and Services portfolio, because basically they are providing some of the funding for this kind of initiatives. And also I want to acknowledge the work that Meg has done in organizing or helping me in organizing this Indigenous Seminar Series. I would like to invite Professor Celine Boehm, the head of the School of Physics, to introduce our guest speaker today.
Thank you, Jaime. Can you hear me? Yes? Okay, thank you. So thank you, everyone in the room today. As Jaime said, it's great to see a lot of people and a great turn up for an astronomy seminar. So it's an honor for me to present our inspirational guest speaker today, Professor Ray Norris. Professor Norris is an astrophysicist at CSIRO and also works at Western Sydney University. His professional life revolves around the question of figuring out how the universe evolved from the Big Bang to the galaxies, planets, and people that we see today. He leads the international team, which is the evolutionary map of the universe, and they use state-of-the-art radio telescopes and innovative big data techniques in order to sequence galaxies from the Big Bang to the present day. He tries to answer questions like, why do most galaxies have a black hole in their center, and how does it affect the galaxy's life cycle? Obviously, those are very important questions in this building, and a lot of people are trying to answer them. He's also very well known for his groundbreaking research on the astronomy of Australian Aboriginal people, and his research focuses in particular on the question of how traditional Aboriginal Australians use their knowledge of the sky for practical and also ceremonial purposes. One of our aspects is to understand their development of an ethno-scientific view of how the universe works. So please, everyone, welcome, join me, and please welcome Professor Ray Norris.
Thank you very much for that very nice welcome. Sorry about that. I would like to add my acknowledgements to Hamish of the local Indigenous owners, traditional elders, and also all the Indigenous groups that we've worked with across Australia, especially being a POM, all the terrible things that we've done to them over the years. I'm amazed that anybody's still talking to us, but they do, and they're willing to share their stories and their culture and their knowledge with us, and so I'd like to thank them for that. Okay, so I'm going to talk about the astronomy of Indigenous people, but I what I'm really interested in is to what extent did people do the sort of what we call astronomy. And in Sydney Uni, there's an astronomy department. People don't go around telling stories about the stars, right? They go around trying to understand what the stars are doing, how the universe came to being, what it's doing, how do you explain the phenomena you see, and then how do you use that for practical purposes? How do you develop Wi-Fi? Okay, we're probably not going to get traditional knowledge about how do you develop Wi-Fi, but maybe there are other practical purposes to which people can put their astronomy, like navigation, for example. I apologise for my voice, which is a bit croaky this morning. I'm going to start by giving you an example of what you might call Aboriginal astronomy. This is Bill Yudamdamahani. He's the senior elder of the Waterman people. They're about 300 kilometres west of Katherine in the Northern Territory. And Bill and I are good mates. I mean that in a real way. We're obviously from very different backgrounds, but we share a love of the sky. And for a while we did this stage show where we basically stood on stage and told people, compared our experiences. I'd go on about the galaxy and black holes, and Bill would go on about his traditional stories about the same part of the sky. I'm going to tell you one of his stories. By the way, everything that I use here, I've either had the permission of the elders to use it, or it's in the public domain. So Bill tells the story that in the Waterman tradition, when we die, our spirits go up to the sky. And they don't just go up any old how. Our spirits actually go through the star, which I would call Vega, and Bill would call Jalala, and it's not a star at all. It's a wormhole or porthole into the sky in Waterman culture. And our spirits go up through there, they go up into the Milky Way, and they do a whole load of ceremonies to purify their spirits. While they're up there, there's the star I would call Altair, Bill would call Bullion, which is the wedge-tailed eagle, and that Altair is the master of ceremonies for all these ceremonies that go on. But I have a mentor, if I'm a spirit, which is the star I would call Arcturus, Bill would call Munin, which is a rock god. And so Munin takes our spirits through all these ceremonies, and there's various feasts and dances and things you have to learn, and Munin will teach our spirits all that stuff. After a very long time, up in the sky, our spirit comes back down to Earth. And it comes down as a shooting star. And we fall down to the ground, and we make our way to a creek. And we go down into the creek and sit there, and we wait for our potential mother to come along. And one day, we'll see our mother coming along, and we'll jump up into her, and she becomes pregnant, and then a few months later, we're born again, and so it's a reincarnation cycle. While we're waiting in the creek, we're looked after by the rock god. It's the earthly counterpart of Munin, who feeds us algae to keep us going until our mother is able to take over and look after us. So that's the Waterman reincarnation cycle. And obviously it's really beautiful. There's lots of details I've left out, lots of very beautiful details. But is it astronomy? And I'd actually say no, it isn't. It's a beautiful story about the sky, but it doesn't involve any of the stuff that I would really call astronomy. And the reason I got into this area, I was really interested in the question, is Aboriginal astronomy just about telling beautiful stories, or is there more to it than that? And that's really what I'm going to talk to you today. As you're aware, there's many different Aboriginal groups in Australia. That's Bill's mob from up there. I'll be talking quite a bit about stuff and the younger people. My wife and I went up to Arnhem Land every year for a number of years, sharing stories and so on. And I'll also talk about some of the local groups, Kurungai, Uarla and Kamilaroi. So the question that I'm really interested in as a research question is, did Aboriginal people hundreds of years ago, firstly, did they know the sky in detail? Could they actually name stars and things like that? Could they do things, something I call the Stonehenge hypothesis? Could they predict where on the horizon an object would rise or set? Did they make any measurements, or did they try to understand phenomena like tides or eclipses. And those are the sorts of things I'm interested in. Let me start with a very beautiful local constellation, the Emu in the Sky, which is, of course, the Milky Way. And many astronomers in the audience, I don't need to say that there's the Southern Cross there, the stars on our flag, and then there's the Milky Way going across there. Now, this constellation, the Emu in the Sky, is not about those stars. This constellation is about the spaces, the dark bits in between the stars, which astronomers know are the clouds from which new stars are born. So right next to the Southern Cross, you've got this black bit, and that's the head of the emu, and you can see its beak sticking out like that, and its neck coming down like that, and its body there. And it's even got a pointy back like a real emu, and the legs going down there. And it's not very dramatic when you see it on a slide like that, but if you go out into the bush, you really do need to go out into the bush. You can't see it from anywhere around Sydney. Go up to the Blue Mountains or, I know, Royal National Park, something like that. And you look up and you're looking for, you think of constellations like the Southern Cross, and you're looking for this group of dots. You're going to join the dots with lines and imagine some shape there. And it's really not like that. You look up there and there's this thing right across the sky like this, about 90 degrees across. And it's an enormous great thing. And once you've seen the emu in the sky, your view of the sky is never the same again. You can never unsee it. And it changes your perspective of the sky. And the emu in the sky is known or talked about by probably most of the cultures across Australia, in pretty well every state. And I sometimes get into trouble if I give a talk like this to an indigenous group, let's say in WA, actually happened in WA, and I'm saying how the Yolngu people see it and the Wurundjeri people see it. And one of the elders came up to me, quite offended up. All very well, you're talking about these other groups. It's actually ours. They may have appropriated it, but it's actually ours. And that's the problem. It is a very personal thing. And each of these groups feels it's theirs. Anyway. So I've said where it is. So if you want to see it, you look for the Southern Cross in the south. You find the coal sack, that black cloud next to it, the head of the emu. And then you just follow across the sky, and you'll see the rest of the emu. Oops, and if you haven't seen it, that's what it looks like. Okay, now, in Sydney, we have these wonderful rock engravings all over Sydney. These particular, as completely random ones, you can see this lovely pair of wallabies, and you can see this man standing next to them, and you see it's definitely a man, not a woman. There are just thousands of beautiful engravings like this all over Sydney. Very underappreciated. Beautiful rock art in Sydney, and you don't hear about it very often. How many people have actually visited a rock art site in Sydney? Oh, wow. Almost everybody. I'm talking to the wrong audience. Usually when I ask that question with a public group, you get a few people put up their hands, and I tell them where to go. But anyway, I'm going to talk about one particular one, and this photo here is taken by my son Barnaby, who's a postdoc here at Sydney Uni in astronomy. There's the emu in the sky up there. You see the head there, the beak, the neck, the body, the legs. And here, this is at the Albina track in Ku-ring-gai Chase National Park. You can ask national parks how to find it. And you can see this engraving, this beautiful engraving on the ground of an emu. And there's a couple of curious things about it. For example, its legs don't really stand up like an emu's legs, and yet the rest of it is anatomically really correct with sort of the gizzard, or I don't think it's actually called a gizzard. I think it's called something else, but I call it a gizzard anyway. But the shape of the back and everything is very accurate, and yet the legs are in the wrong place. And a few years ago, my colleague Hugh Cairns, and I should say, this is actually, okay, it's photoshopped, this image, but it is accurately where the sky appears above the engraving. And you can see that the representation on the ground accurately matches the representation of the sky, including those legs being drawn backwards. And a few years ago, my colleague Hugh Cairns suggested maybe this engraving is not a picture of a real emu, but is a picture of the emu in the sky. And the problem is, of course, that the legs of a real emu fall down like that. And they never trail behind, even when an emu is running. But there are legends around Australia way back in the dreaming that emus used to fly, which is why the legs fall back like that. So, is this hypothesis correct? I have to say I was a bit sceptical, as scientists tend to be, of this hypothesis until we noticed a few things. Firstly, this orientation really is perfect. That really is exactly how it looks, or would look if you didn't have all the streetlights around. And the orientation is right above, lines up perfectly with the engraving on the ground. The second thing is that this orientation happens when the emus are laying their eggs in autumn or winter. And we know that emu eggs are a really important food source for the Guringai people. The other thing is that the emu in most Aboriginal cultures is associated with initiation. And we know this site is an initiation site. I'll just tell you why it's associated with initiation. As you probably know, emu mothers lay the eggs, obviously, and then they run off and have nothing further to do with the eggs. And it's the males that hatch the eggs, bring up the young, and so on. And so there's an analogy, many Aboriginal groups see this as an analogy with the way that Aboriginal males bring up the boys. Obviously, the women give birth to the boys, but it's the men who turn the children into men. And so the emu is seen as symbolic of this process. And we know that this Elvina site is a male initiation site. And we also know, by the way, that in New South Wales, often the initiations are timed for the time of year when the emu becomes vertical in the sky in the evenings. So there's lots of circumstantial evidence. So I think we've got no cast iron evidence that is a picture of the emu, but there's certainly a lot of circumstantial evidence it ties together. Let's talk about another constellation, Orion. That's how Orion looks like. I'm guessing everybody here knows what Orion looks like, right? You see it around Christmas. You see the three bright stars there, and the Orion Nebula below where stars are being born. Well, the reason it's called Orion is because it's named after this Greek hunter, and the three stars are supposed to be his belt, and the Orion Nebula is his sword. But this is amongst the worst of the European constellations, because nobody in their right mind would interpret that as that, really. You know, it needs a fair stretch of imagination. It's even worse in Australia, because actually he's like that. So why would you see this group of stars? Oh yeah, I recognise that. It looks like upside-down Greek hunter. Certainly the Aboriginal people didn't. And so they had their own stories, quite naturally. In Australia, of course, we call it the saucepan, which has got the virtue of being the right way up. But Aboriginal groups you get different stories across Australia. But I'm going to tell you one from Yolngu people in Arnhem Land. And they say that Orion Jumpan, as they call it, is a canoe, and those three stars are three brothers. Those three brothers went out fishing and hunting one day. They were from the Kingfish clan, and all they could catch were kingfish. And it's taboo to eat kingfish, like eating your grandfather or something. A, illegal, B, yucky. Anyway, one brother caught a net of kingfish, and the son was so angry when she saw this that she created this whirlwind and blew them up into the sky as a punishment, and also so they'd serve as a warning to other people. And then you see the nebula there is the fish still attached to their canoe. Okay, so that's a nice story. Nearby we have the Pleiades, the Seven Sisters, And, okay, you can guess, they're named after Greek gods. The Pleiades were seven girls, and of course, okay, they're upside down. So when you look at the Pleiades, they don't obviously look like 7 upside down girls. By the way, there's a myth you sometimes find in the anthropological literature which says that Aboriginal people can't count beyond 5, which is interesting given that many groups call this the 7 sisters. And they do have a word for 7 in their language. You know, that's another argument. But it's, there's a lot of myth around. So there are various stories about the 7 sisters. This is a story told by a Yolngu lady who passed away a couple of years ago, but was a very well-known leader. She says 7 sisters come back with turtle, fish. We can read the rest of it. The point is that she's saying that when they see the 7 sisters in the sky, they know it's time for these various foods. And you might say, well, why would people want to do that? So these people are hunter-gatherers. They know when the nuts are ready, when the berries are ready. They just go and pick them off the trees. Well, no, actually. If you're like the Yolngu people are, or were, nomadic hunter-gatherers, what that means is that you have an annual cycle of camps on your land, and you move around from camp to camp at different times of the year. So you need, in Arnhem Land, you need to get up onto the escarpment to get all the nuts and berries at the right time of year before the birds get them. So you might be down in the river catching barramundi, and you've got to know that it's time to go up to the escarpments. Similarly, you need to come down again. They eat water chestnut roots, riker, they call them, and the magpie geese eat these very quickly. So again, you've got to get down just at the right time of year to eat these. And so they actually use stars as part of their calendar to tell them when to move camp. And so this is one example of that. And then they build it into the stories and culture. So at the beginning, I asked, are they interested in the sky? Do they know the sky? And obviously, yes. Do they use it for anything useful? Immediately, yes. They're using it for calendars. Now, there's another interesting thing, is that this is from another group in Northern Territory, the Koyima people, and this guy says, you see that mob of stars there? He's talking about Orion. We blackfellas call him Manbook, and all day he chased that mob of girls over there. That's the Pleiades. Now, that's odd, because in the Greek mythology, Orion chases the 7 sisters. Orion chases the Pleiades. And here we have the same story again. And curiously, we get the same story right across Australia, different versions. It looks exactly the same, but in nearly every Aboriginal culture, Orion is either a man, so there they're saying he's a fellow called Manbook. I told you in the Yolngu story, he's a group of 3 boys. In nearly every Aboriginal culture, Orion is a young man, or a group of young men, or a group of hunters, or fishermen, or something like that. And nearly always, the Pleiades are a group of young girls, and the young men in Orion are chasing those girls. So that's very mysterious. There's also a problem that why are there 7 sisters? Oops. When you look at those, most people can only see 5 or 6 stars. Nobody sees 7. Why are they called 7? Even in the Greek stories. And there's a whole another story there, which I don't have time to tell you. You can ask me about it at the end, maybe. But the last time there's any cultural contact between Europeans, who know the Greek story, and Aboriginal groups, well, obviously over the last 200 years, there have been plenty of opportunity for people to share these stories. But we think these stories are really, really old. You find them in very old paintings and so on. And so we think they go way back. And there was no cultural contact between Aboriginal people and Europeans since about 100,000 BC, when we all came out of Africa. And so I like to speculate that the reason these stories are so common is because these were stories we were telling ourselves around our fires in Africa 100,000 years ago. But that is a hypothesis. It needs to be tested. Okay. Let's move on. I mentioned Walu earlier, who created she's the Yolngu Sun Woman. She created the whirlwind, which blew the boys up into the Orion constellation. And in Yolngu culture, she's a lovely old lady. She gets up each morning, decorates herself with red ochre. She spills a bit, as you can see, and sets fire to a stringy bark tree, carries it across the sky, giving us light and heat. The moon, on the other hand, is a really bad guy. You know how the moon changes phase over the course of the month? There's a good explanation for that. The moon man, again, this is a Yolngu story, it's called Nyalindi in Yolngu, and he was a big, round, fat, lazy guy. Oh, there he is. And he didn't get any food. Left his wives and his sons to get all the food and everything. And they got pretty angry about this, and so they started attacking him with their axes and cutting bits off, as you can see, until finally he dies. And when he died, he remained dead for 3 nights, and he was fairly annoyed about that. And he came back to life, and then cursed the world. He said, right, from now on, when any animal or person dies, they stay dead, except for me. I'm going to come back to life if you kill me. And so he's a really bad guy. He brought death to the world. The story I've just told you, the Yolngu story about him being fat and lazy, that's the children's story. There's different levels of stories, and in the deeper levels of stories, he commits other crimes, taboo crimes, incest and so on. And so there's another common feature of these stories. Okay, so the interesting thing is that somebody's tried to explain the phases of the moon in that story. What about eclipses? We know you know how solar eclipses, I don't need to show this slide to this audience, but a solar eclipse, if we're standing on the Earth looking at the sun and the moon comes across and gets in our way and creates this spectacular solar eclipse, and then as your eyes adjust, you see all this light coming out from there. Who here has seen a solar eclipse? It's a very atypical audience. I don't normally get those. But it is, those of you who have seen a solar eclipse will know, I first saw mine in 2012. In fact, even got a photo of it. I'd heard all these stories about how it's a very mystical experience and so on, and being a scientist, I was totally sceptical about all this. And I was amazed at the visceral effect that it has on you when you see it. When, the sky goes dark in the middle of the day and the strange winds, strange shadows and so on. That photo, by the way, it's going completely off topic, but I can't resist telling you. You can see the shadow of the moon on top of the atmosphere there. So those people over there are still in sunlight, but we're standing looking at the eclipse. We can see the shadow of the moon. That photo, by the way, was taken with an iPhone. Nothing fancy. Okay, right, back on topic. So did Aboriginal people try to understand what caused these eclipses? There's this lovely story of a lady called Mrs. Peggs in the north of WA in about 1900. And she received a letter from England which said, in a month or so's time, you're actually going to have a total solar eclipse where you live. And she was fascinated by this, and she's fascinated by the local Aboriginal culture. And so, through an interpreter, you can imagine British people at the time, the colonial attitudes in 1900. She's probably more liberated than most, but even so, you can imagine they'd sort of have visions of the natives running, screaming as their god disappears or something like that. So she, through an interpreter, she asked the elder about the eclipse. She said, do you realise that in a few days' time, in the middle of the day, the sun is going to go dark, and it's going to get very cold, and birds will go back to the trees, the dogs will bark, you get strange shadows, you'll feel weird. And the elder said, what, do you mean like a solar eclipse? So people have been in this country for at least 50,000 years. They've seen a few solar eclipses come and go, and they know about them. Nevertheless, actually, it's interesting because if you stay in one spot, you'll only see a solar eclipse every 8 generations or something. So the fact that an elder knows about solar eclipses means that this knowledge has been passed to him, not from his father or his grandfather, but from 8 generations back. people have been telling the story even though they've never witnessed it themselves. So it's a remarkable testament to the continuity of the knowledge. Anyway, so we get various explanations from across Australia, but often it's around the theme that an eclipse happens when the sun woman makes love to the moon man and his body covers hers. And the interesting thing is that that's a completely correct scientific explanation. Okay, we don't talk about moon man things, but it's dressed up in the cultural context, but otherwise it's completely correct. And there's other stories, more complicated stories, which I don't have time to tell you about lunar eclipses and how again, that's when they make love, but in this case, the moon man is waving backwards and forwards trying to escape the sun, which the moon has very complex motion. And we see here that people have been trying to figure out, they've watched an eclipse and think, what the heck, what on earth caused that? And they've come up with these explanations. And we see these explanations in their mythology. So we think they sort of understood eclipses. What about tides? So you may wonder why I've got a picture of Venice there to illustrate tides. There is a reason, actually. So we all know that the sea level goes up and down a couple of times a day, and it's, I'm not sure how widely known it is, that actually depends on the phase of the moon. So when the sun and the moon are lined up, they have a bigger combined gravitational pull on the oceans than when they're at right angles. And so as a result, when you have a full moon, so this is the height of the tides, happens to be in Arnhem Land, but full moon goes up and down quite high every day. First quarter, not so much. The new moon, really high. And the last quarter, not so much. And so if you want to explain tides, you've got to explain not only firstly, why does the water go up and down? Why does it go up and down twice a day? And why does it depend on the phase of the moon? Those are the three things. In a good theory of tides, those are the things you want to explain. Let's compare two explanations, Galileo's explanation and the Yonyu explanation. Now, I know Galileo is a great scientist. We're all in awe of him, but we all have bad days, right? And what I consider his greatest blunder is his theory of tides. And he said it's due to the way the Earth is going around the sun. And as the Earth turns and its motion either adds or subtracts from the orbital motion, and so the water sloshes backwards and forwards. That's why you get tides. It's completely wrong. And not only is it completely wrong, but only predicts one tide a day. And Galileo is known for testing scientific ideas by doing experiments. How did he ignore that observational evidence? I've no idea. It's his bad day. Now, Kepler did suggest the tides caused by the moon, and Galileo called it a lamentable piece of mysticism, or in Italian without the English accent, is what he said. Yeah, he was completely wrong. What about Aboriginal explanation? So this explanation for the waterman people, it's funny. I'd asked Bill several times, do you have an explanation for tides? He basically said no, until it was just a few months ago we were filming something with a Japanese TV program, and he was explaining how the moon raises up by something like magnetism, raises up the water, and that's what causes the tides. And the reason he hadn't told me before, because I'd asked him out of context, and there's something I've sort of realised over a period, if you ask an Aboriginal elder an isolated question out of context, they often won't know the answer. But if you say, tell me the story of X, the answer to that question may well come up during the course of the story. And it's a bit like people who memorise packs of cards. You know, you get these people on TV, and you show them a pack of 52 cards, they'll memorise the sequence, be able to recite it perfectly. And it's because they've remembered the sequence of events. If you say, where in the pack is the ace of spades, they'll have absolutely no idea. They've got to go through the whole story. And I think some of you may be familiar with the, it's got various names, but memory palace and things like this. I think these stories are often the way of memorising all this information. Anyway, so Bill did have an explanation of tides. We'd also heard there's a very complex explanation for the Yonyu people and for some years, my wife and I were trying to find somebody who would able to tell us the story. And this is us driving around looking for somebody, and it's actually a totally lame segue, just to say this is us driving around Arnhem Land, driving through creeks, and that creek is full of crocodiles. And you don't want to stall the engine halfway across if you possibly avoid it. Anyway, but the younger explanation is that, okay, you're on the east coast of Australia, you see the moon coming up through the ocean. And you notice that when you've got a full moon, the water level goes up and down by large amounts. And their explanation is that as the moon comes up through the ocean, the water falls into the moon or gets poured out of the moon. And obviously, when you've got a full moon or a new moon, there's a lot of water going in and out. And when you've got a half moon, not so much water. So that's why you get big tides. Now, the interesting thing about this, you might say, well, that's a bit weird. But given the information available to them at the time, it's actually a perfectly good explanation. And it has predictive power. I can go along to a young man and say, what are the tides going to be like this evening? And he can look up at the moon and say, oh yeah, it's going to be a full moon at 8 o'clock. And it's going to be a really big one, because of the full moon, and so on. And so it is like science. We sometimes call this ethnoscience. So they're trying to understand the universe around them, but within their own cultural context, and obviously with the information available to them. But this is a bit similar to science. But it does have predictive power, unlike Galileo's exhibition, which was completely wrong. So, I gave this talk in Italy, actually, once. This went down like a lead balloon. Okay, so I hope I've shown you that people were interested in the sky. They're trying to understand how the sky works. I'm going to talk a bit about navigation now. How are we doing? Okay. It's been known for a very long time that Aboriginal people traded across the country. And I think this is from 1939, this map. And McCarthy was talking about how they trade ochre over very long distances, and we now know they trade all sorts of things, tools and stones and dances and stories as well. And it was real trade. And what I find curious about, you go back to all the great anthropologists of the last century, and none of them ask about navigation, which I find very, very weird. They knew they travelled across the country, but I think it's a sort of cultural bias. I can say more about that later if necessary. So how do they navigate? So when we go around the country, we find different groups have got different approaches to this. So this is an image from the Warlpiri people in the Central Desert, and they have a very strong identification between law, I think, is east, language is north, ceremony is west, and skin is south, and country is where you are here. And so they have a very similar idea as we do to north, south, east, and west, and build it into their culture. Bill Harney says how the blue-tongued lizard gave the cardinal points to the Waterman people by throwing 4 boomerangs in the 4 cardinal directions and naming the 4 cardinal points. So clearly really important in these cultures. Not every culture, some other cultures don't have these Western-style definitions of the cardinal points. But clearly, once you've got that framework, you can start navigating. And one of the questions we can ask is, how well did they actually know those directions? If I ask you where west is, you might say, well, that's easy, you just look at where the setting sun is. That's wrong, actually. The setting sun will be anywhere from northwest to southwest, depending on the time of year. So how accurately could these people point to west? A few years ago, my colleague Dwayne Hammaker and I looked at these stone arrangements in New South Wales, and there's a sort of, it was said, without any real evidence, that a lot of these things tend to be north-south. And so we went around surveying some of them, and they're just lines of stones. We don't actually know what they're used for, but we're just looking at their orientation. And on this page, up is north. And when we made a plot, a histogram of these directions, well, the first thing you see is that, yes, a lot of them indeed are north-south. So, sorry, this is azimuth. So 0, azimuth is just the bearing. 0 is north-south, 90 is east-west. And that's back to north-south again. And so you see, yes, there are a lot of north-south ones. There's also a lot of east-west ones. What's really interesting is that these data are in 5-degree bins. And you look at the width of that, and you can see that when they set up these stone rows, they're doing so with an accuracy of less than 5 degrees. And that is really surprising. How would you build a stone row with an accuracy of 5 degrees? It's really hard. You've actually the only reasonable way is to make astronomical observations. So, for example, one of the things you can do is see where the sun sets every day. You put a stick in the ground. Over the course of a year, you'll see the sticks in different places. But the midpoint of all those sticks will be due west. So do we see any evidence of any process like this? There's a site down in Victoria called Wurdi Youang. It's a stone ring about 50 metres across. And as you can see, the stones are, the highest stone's about waist height. There's an aerial view. It's not actually circular. It's more sort of rounded kite shape. I'll show you that shape if you haven't seen it. And at the top of the hill, where which is also the blunt end of the kite, are 3 very large stones at the height point. And those 3 stones, they're sort of like, when you're there, they look like they're the sort of focal point of the whole stone arrangement. And that's what they look like. And you can see that that's for scale. It's about a metre high or something, a bit more. Okay, so a few years ago, a colleague of mine, John Morrison, suggested that this might be astronomical. Yeah, you guessed it, I was sceptical, as we always are. And so we went to survey it. What he suggested was that when you these are the big stones here, and beyond the big stones, these little stones sticking out of the glass, which we call outliers. And he said, if you stand at the big stones and look out over these little stones, in the middle you're looking at the direction of where the sun sets at the equinox. If you look over that stone, you're seeing where the sun sets on Midwinter's Day, and that's where you see the sun setting on Midsummer's Day. And so we surveyed the site to see if it was real. Well, okay, his measurements were correct. Those outliers did indeed line up. But then you worry about things like hoaxes, you know. Okay, these big stones would take a lot of moving, but these little stones wouldn't be that hard to move. Could it be a modern-day hoax? Somebody who wants to see an Aboriginal Stonehenge? Or could it just be random chance? What are the chances of getting... So there's one stone there, doesn't do anything at all. Is there any chance that we just selected random stones and then imposed our own Western and cultural ideas to make it seem more significant than it was? So we have to test all these hypotheses. When we did the plan, it looked like that, and we were astounded to see that, in fact, these directions will not just mark, those are the directions I just talked about, over the small outlier stones, but actually the whole design of the ring, it actually has 2 straight sides and a sort of bumpy rounded bit, but the 2 straight sides also point in these same directions. In this diagram, I haven't fitted these lines to the stones, I've just moved those lines over, keeping the direction, and then magnified them in Photoshop. So they are indeed a very good fit. Let me just show you, this is actually from the NHK program they made about this. It's just a good way, oh dear. Come on, you can do it. That's it. So you can see that the 2 lines I've just spoken about there. So if you stand at the vertex, you see the sun sitting there on Midwinter's Day, and there on Midsummer's Day, and down there is due west, where it sets at the equinox up to those are the big stones there. And so not only have we done a survey of this site and confirmed that these directions are indeed correct, but we've also done a statistical analysis. We did a Monte Carlo test, effectively building up to these stone circles in a computer model and seeing what are the chances of getting this by chance, and the answer is like 1 in a million or something. It really is very unlikely to be a chance alignment. And the fact that you see those lines on the big stones makes it very unlikely that it's a hoax or anything like that. So we're now pretty well convinced that this stone circle, for whatever reason, really was built to indicate those directions. And people really were making astronomical measurements. Okay, so how are these directions used for navigation? If you ask Bill how does he navigate, you have to appreciate, firstly, that Bill has a fantastic mental map of the sky. He can name just about every one of the 5,000 stars you can see with the naked eye, and there's a story about most of them. And for Bill, he carries this image of the sky around with him. So I might see Orion, that's deck -5 degrees, none of that stuff. He adjusts the map with the time of year, and he'll just glance up at the sky and tell you where west is, which I find an amazing ability. So he can navigate using the concepts of direction and also the stars. I'm running a little bit over time. Is that okay? Yeah, okay, that's good. Okay, there's another way of navigation which is really interesting. First of all, I'm going to take you back to ask the question, why is Venus always low in the sky? So we astronomers know the reason is because Venus is on an orbit inside the Earth's, and so whenever we see Venus, it's always very close to the sky. So right now, the sun is high in the sky, Venus is up there somewhere, there's no way we're going to see it against the glare of the sun. The only time we'll see Venus is just before sunrise or just after sunset, and Venus will be low on the horizon. So that's why you only see Venus slow down. What about the Yolngu explanation? So they call Venus Barnabia, and they say she was a spirit who came. She actually brought the first humans to Australia, and she landed across the coast at this sacred place called Yarapai in Arnhem Land, and then she guided these people towards Australia. They'd come from this mythical island Balco in the east, and singing this song. And as she flew across the land, she sang this song. The reason she didn't get very high in the sky is because her sisters back on the island of Balco were worried about her getting lost if she flew too high. So they tied a rope to her, and that rope stops her from getting too high. And so she flew along, guiding these people, held down by the rope, and singing this song. And this song goes on forever and ever. No, not literally forever and ever, it seems like it. No, I didn't say that, please. I didn't say that. I didn't insult so many. But it's only a very long time. They have this morning star ceremony. It starts at sunset and goes right through the night until the following morning, till sunrise, including Venus rising. And involves this morning star pole here. And during the ceremony, an elder will hold the morning star pole, and he is able to communicate with Venus through it. That tuft of magpie goose feathers represents Venus. He can talk to Venus. Venus can communicate with the ancestors who live in Balco through this rope. And so this is a way of having an occasional communication with the ancestors. It's part of the funeral process. Anyway, the song she sings is, that's part of it. But then she goes on to describe the coastline, the mountains, the water holes, who lives where the boundaries are. She lays the basis of Yolngu law. But this also forms an oral map. If you know the words of the song, supposing you're travelling west from Yirrkala and you come to a mountain and you go through Venus' song, and she says, to the north of this mountain is this great camping ground, there's good water hole and so on. To the left is swamp, you don't want to go there, and so on. And you can navigate using these songs, and these are called song lines. And people are using these right across Australia. So I've got a bit out of sequence. There's an elder, Ghani, dancing the morning star ceremony up on Elcho Island. You see his morning star pole there. Okay, so this all works well. The only minus is, of course, there's no rope. There's no rope holding things down. And I made this comment to one of my Aboriginal friends, and she said, yes, there is a rope, you haven't seen it. And I said, no, there really isn't. I mean, we use the Hubble Space Telescope and think we would have noticed if there's a rope. And she said, well, you white fellas haven't looked carefully enough, you know. So we went out the next morning. You can probably see the rope, actually. It's what we astronomers call zodiacal light. And I just, in case you can't see it, I've just photoshopped it to make it a bit more obvious. And I think this zodiacal light is caused by sunlight scattering off dust in the solar system. I'd totally forgotten about it, but there is a rope, after all. Totally forgotten about it. So you only want ray zero. We scientists aren't very good at this stuff, I think. But these song lines are found all across Australia. We had a wonderful project led by my then student Bob Fuller at Macquarie Uni, where we worked with the Urali people on their song lines. The Urali and Kamilaroi people are really trying to rebuild their culture, and so it's very nice doing a bit of research where it's not us as scientists coming along with metaphorical clipboard asking questions, but it's very much a partnership. We're working with the Kamilaroi and Urali people, helping dig out the old stories and cross-correlate them and chuck out bits which don't seem to fit and try to build up what the original story was. Anyway, so they have song lines which will help them navigate. This is one, if you want to go from Carnarvon Gorge down to Garuga in northern New South Wales, and you go through these towns along the way, and they actually map these towns onto the stars of Scorpius. Now, they're not using Scorpius to navigate, I should make that clear. What they're using Scorpius as is a way of memorising the song. So they have a song as they travel from northern New South Wales up to Queensland. They will use the song to help them navigate, which tells them where the river crossings are and so on. And to help them remember that song, the kids will look up at the stars and sing the song and go through the stars in the sky. And that's how they memorise the song. And they can look up at the stars to remind themselves of the song. Bill uses these song lines. He tells a story of when he was a little kid and his father, not his biological father, but the man who brought him up, Joe Jamorni. It's amazing we've got a photo of him. It's very pure coincidence. He was asked by the whitefellows, they're living near Katherine, the whitefellows asked, can we have an Aboriginal navigator take us up into WA? And Joe Jamorni did the navigation, and he took Bill along, so Bill remembers the little kid walking along with his grandfather, really. And his grandfather singing the song to navigate, singing the song line. And walking along, singing the song, navigating, using the song. Behind him were the whitefellows blazing trees with their knives. And behind him were the 1930s bulldozers, which were bullocks pulling a log and making the road. And that road we now call the Victoria Highway. And we find this right across Australia, that many of the major roads actually follow song lines. I'm running out of time, so very briefly, the Great Western Highway also follows a direct song line, and we see carvings along the way which tell us, which go outside the territory of the Darug people. Okay, so I'm going to finish there, and well, I'll stop there. Thank you very much.
Thank you very much. We have time for one question. If you don't have questions, I would like to give this kind of acknowledgement for coming here today.
Thank you very much. That's very kind of you.
Yes.
Thank you.